guys, this is Mrs. Bolin here with your notes for 11.1, where we will learn about factoring polynomials using a greatest common factor. So first we'll go over the warm-up just to kind of tap into some prior knowledge. So when we are simplifying, we distribute the number that's out in front of the parentheses to everything inside the parentheses. Because remember, those parentheses mean that we are multiplying what's inside with what's outside. So 3 times x is 3x, 3 times 2 is 6, and we use the positive, the plus there, to separate our two terms. So if it were a negative, you just put the minus there, but you have to have a plus or minus to separate those terms. So that would be the answer for that one. Then we're going to do the same thing with the next problem. So we've got negative 2 times 3x, which is negative 6x. Then we have a negative times a negative, which is a positive, and 2 times 4 is 8. But for the next problem, because we've got two things in the first and two things in the second, we could think about it as repeated distribution. The x goes to both of those and the 2 goes to both of those. Or we could organize it using a box, kind of like a Punnett square if you've done that in science at all. So we've got x plus 2 and x minus 4, and I made those boxes super tiny. So x times x is x squared. X times negative 4 is negative 4x. X times 2 is 2x. And a positive 2 times a negative 4 is a negative 8. Then we start with the highest exponent so that we get our answer in standard form. So we have x squared, the 2 being the highest exponent. And then you can see we have, sorry, my big old arm there. We've got negative 4x and 2x. And if we've got 4 negatives, 1, 2, 3, 4, and 2 positives, we've got negative 2 x's left over after we cancel those. And then we've got a negative 8 at the end there. So whatever method you use, whether you used FOIL, first, outer, inner, last, you did repeated distribution, or if you use the little box, no matter what method you get, you should all get the same answer. So we're going to do another one of these. I'm going to do repeated distribution this time, just to show you something a little bit different. So I'm going to put the 2x, and I'm going to multiply it by x and by 5. So 2x times x is 2x squared. 2x times 5 would be 10x. Then I'm going to do the same thing for the negative 3. Negative 3 times x and negative 3 times 5. So I've got minus 3x, or a negative 3x, and I've got negative 3 times 5, which is a negative 15. And then I'm going to combine my like terms. So there's no other x squared, so that one just comes straight down, 2x squared. Then I have 10x take away 3x, which is 7x. And then I do minus 15 at the end. All right, and that's it. So hopefully you guys remember that from last week, because what we're doing this week is the same thing but backwards. So looking at our notes, what we're going to start doing is pulling out factors. So last week we multiplied things together, and now we're dividing them back out again. So we're just saying, here's the answer. What was the question we gave you? So just looking at the problem in the opposite order. So we're going to just go ahead and jump into some of these practice problems here. But you guys will remember GCF probably from middle school, where that's the biggest number that goes into all of the numbers that you're looking at, okay? So right now I'm looking at 12 and 15, and I'm gonna think, what's the biggest number that goes into 12 and 15? And there's different ways to do this. You guys could look at your multiplication chart. We could list all the factors and circle the ones that are the same. I'm gonna say, well, I'm just gonna subtract them. Sometimes that helps. And 15 take away 12 is 3. So there's a difference of 3. And then I think, can 3 go into both of those? 3 goes into 15, 3 goes into 12. And so that one does go into both of them. So I'm going to put a 3 right here. And then you're going to say, well, there's 1x here and 3 x's here. So I want to circle the most that they have in common. Okay, they both have in common 1x. So that's the most that I could pull out of both of them, okay? So our answer is just 3 and x, but being multiplied, we want to put our factors all together. So 3x there would be the answer. So I'm going to do the same little trick on this one. Doesn't always work, but if you subtract them, I get a difference of 10. And sometimes that's a good place to start. Sometimes it doesn't help you at all. Like down here, you'd say, oh, difference of 6 doesn't help. Okay, but sometimes that's a good place to start at least. So I have a difference of 10, and in fact, 10 does go into to both of those. So I'm gonna say I can pull out a 10, and then I'm gonna say there's 3 y's here and 2 y's here. So what is the most that they have in common? The greatest common factor would be 2 y's. So the way that we write 2 y's like that when they're multiplied is by y squared. Another way to do the numbers, if I had the 12, you could say, oh, well, that's 3 times 4, which is 2 times 2. And then 15 is 3 times 5. And you say, what do they have in common? There's a 3 in each of them. Okay, we could have done the same thing for the 30 and the 20. So 30 is 3 times 10. 10 is 2 times 5. And then 20, sorry, that's a 3. 20 is 2 times 10, which is 2 times 5. And you'd say, oh, well, they both have a 2 and a 5, which is multiplied to make 10. Okay. So then for our next ones, we are actually going to factor out the greatest common factor. So if I look at problem number 3, I see that I don't even have any numbers over here. I just have a 1. So it doesn't really make sense to pull out a 1 because it wouldn't change anything. But what I want to see here is that I have 2 A's and I've got 1 A here. So I'm going to say, well, what do they have in common? The only thing we have in common is one of those A's. So if I'm going to write it as a factor, I'm going to put the A on the outside of the parentheses and say, well, what was the original question like if that was my answer? A times what makes A squared? Well, I would just need another A. And then A times what would give me 5A? I would just need a 5. Okay, so that is our answer. Seems kind of crazy, huh? Where if you multiply that out, that's the answer we'll get. We're looking for what was the question in kind of multiplied form like that. Another way to find what's left on the inside is to take your A squared plus 5A and divide it by whatever you're pulling out. So you'd see on this part, the A's would cancel and your 5 goes right there. If you have 2 A's and you're dividing by one of them, you've just got 1 A left and that one goes right there. So that's another way to do it, especially once the problems get a little bit harder. Sometimes I just have my students write it right underneath and see after it all cancels what's left. So let's go ahead and look at problem number 4. Well, this one I would say, well, 3 and 9 both have a 3 in common, right? 3 can go into 3, 3 can go into 9. And then I'd say if there's 2 S's and 1 S, the most that they have in common would be one of them. Okay, because I can't pull 2 out if I only have 1, right? But I have at least 1 in each of those terms. So I'm going to pull out an S. Oops, I didn't leave very much room for that. Sorry. So then I have to say, well, what's left? So remember how I told you, whatever we're pulling out, 3S, 3S, write it underneath and see what cancels. And whatever's left is what goes in the parentheses. So S divided by S, those ones cancel. 3 goes into 9 3 times. This one, the 3's cancel. Well, if I've got 2 S's on the top and 1 S on the bottom, then it would cancel out the second S, but there'd still be an S left and there'd still be a minus 3. So that's what I'm going to write, S minus 3. Okay, you can also ask yourself, if I have 3S squared, and I'm pulling out the 3S, what do I multiply 3S by to get 3S squared? Well, just one more S. If I have negative 9S and I had 3S right here, what do I multiply 3S by to get a negative 9S? Well, it would just be a negative 3. All right, let's do a few more of these because great googly moogly, there are a ton of homework problems. Lots of practice. These are kind of short problems. It's not like some of the long ones we've done before. So now what if there are 3 terms? The greatest common factor has to be in all 3 of them. Okay, so another strategy that's kind of a shortcut is look at the smallest number. And can 2 go into 4 and 8? Yes, it can. So that's the greatest thing I can pull out of all of them. So I'm going to put a 2 out in front. And then this one has 2 X's. This one has 1 X. This one doesn't have any X's. So what's the greatest common amount of x's I can take away from all of them? Well, since this one doesn't have any x's, there's no amount of x's I can take away from all of them because this doesn't have any to give. So all I'm doing is pulling out a 2. So what I want you to think about is divide by 2, and we're going to put what's left on the inside so that when I multiply by 2, multiply by 2, multiply by 2, I get the same thing up here. So 4 divided by 2 is 2 with the x squared. Negative 2 divided by positive 2 is negative 1. But remember, when we have an x there, we don't really write the 1 in front of it. And then 8 divided by 2 is 4. All right, question number 6. So now I'm going to look at these, and again, I'm going to check for the smallest value. And anytime it starts with a negative, I want to pull that negative out because we generally like our leading coefficient on the inside to be a positive. You don't have to, but in general, that's what I would do. And so I'm going to say, well, negative 2 can go into all of those. So I'm going to put a negative 2. This one doesn't have any x's again, so I can't take out any x's. So now I'm just going to pull out negative 2 from all of those. Negative 2, negative 2, negative 2. And I'm going to see what's left. Well, those ones it just cancels, so it's x squared. A positive 6 divided by a negative 2 is a negative 3, and that x just sticks to our answer. A negative divided by a negative is a positive, and 4 divided by 2 is 2. All right, next one. So this one you could see, oh, look, they all have 3. Yes, we got that one, super easy. Then I want you to look at the x's. This one has 4 x's, 1, 2, 3, 4. This one has 3 x's, and this one has 2 x's. So what is the most that they have in common, or the greatest common factor? So this 4 is the greatest number, but do they all have 4 in common? No, so you're just looking, what do they have in common? This one has 2, this one has 2, this one has 2. Okay, so that's what we're going to pull out. We can pull out 2 of the x's. So thinking about what would be left if I divide by 3 and 2 of the x's, well, 3 divided by 3 is 1, which we don't have to write. And I had 4 x's and I pulled 2 of them out. So how many x's are left? Just the x squared. Okay, then I have the minus right there. And 3 divided by 3 is 1, which again, I don't have to write. I had 3 x's. I'm pulling out 2 of them, so I've just got 1 left. And then I have 30 divided by 3, which is 10. I had 2 x's, and I'm pulling both of them out, so I don't write any other x's in there. So that is our final answer on number 7. Moving along to number 8. Again, I'm going to pull out this negative here. This is just a 1, a 3, and a 6. They all have 1 in common, but it doesn't really help to put a 1 there. So I'm going to pull out a negative. Then I'm going to say, well, there's 3 x's here, there's 2 x's here, and there's 1 x here. What do they have in common? Well, they have 1 x in common. And so that's what we can pull out. So I could pull out a negative x. And so then I say, well, what was left? I pulled out the negative. I pulled out 1 of the x's. Well, I've got 2 x's left. So I write that as x squared. I am dividing a positive divided by a negative, which would be a negative, because remember, when I multiply that back in, a negative times a negative will give me the positive that I'm looking for. So it's kind of like we're just doing everything backwards and saying, what would I need to put there so that when I do multiply it, I get this original answer, okay? And then I didn't pull out a 3 or anything. I just pulled out an x, so the 3 stays there. I had 2 x's. I pulled out 1, so I've got 1 left behind. And then this one, I pull out the negative. A negative divided by negative is a positive. The 6 is still hanging out there, but I took away the x. I pulled it out, so it just kind of stays on the outside of the parentheses. And so we just have the 6 left at the end. You can always check your answer by multiplying this back out, distributing it, and see if you got what you started with. Okay, so we're going to go over the odd numbers to your homework. We're going to go over to page 104, next page in your book. And we are going to start with problem number 1 and just go through the odds. Hopefully that will give you enough information to figure out the even ones on your own. All right, looking at problem number 1. Since the littlest number 8 can't go into 10, remember my other little secret shortcut trick was try subtracting them and see what the difference is. So I know that they differ by 2, so I'm going to see, can 2 go into both of those? Yes, it can. So I know 2 can go in. And then I see this one has 2 x's and this one has 1. So the most that they have in common would be 1x. And then I'm going to think, okay, if I divide this one by 2x and this one by 2x, what is left that I would need to multiply in here? So 2 goes into 8 4 times. If I have 2 x's and I'm taking away one of them, I've just got 1x left. So 4x, and this isn't really a math thing. You can't really cancel an x with a squared. I just am trying to show you guys that if you had 2 and you got rid of 1, you would just have that plain old x left. We also have that 4, so both of those go in our answer. We got a plus right there. The x's cancel. 10 divided by 2 is 5. If we multiply this back out, we get 8x squared plus 10x, and that's exactly what we wanted. So good job, you guys, on that. Remember, at any given time, you guys can pause me, try to catch up, try the problem on your own first, and then see if you did it right. So we're going to go ahead and go on to number 3. Oh dear, this is kind of a long one. So remember, my secret shortcuts are try the littlest number, see if it goes into the biggest one. In this case, it does. It goes in 3 times. So I'm going to say I can pull out that negative 15. And then I'd say if there are 5 D's and there are 3 D's, what are the most that they have in common? Well, if you put like 1, 2, 3, 4, 5, and 1, 2, 3, you can see that they each have 3, at least 3 in common. And the other one had 2 left over. If I take rid of those 3's, take out the 3 D's. So I have D to the 3rd power, and then I want to see what's left. So if I divide both of these by negative 15, D to the 3rd, and I divide this by negative 15, D to the 3rd, on the first one, the negative 15's cancel. And we just say, well, if I've got 5 D's and I'm taking away 3 of them, because remember when we divide, we're really canceling, so it subtracts the exponent. So we've got 2 D's left. And then on this one, a positive divided by a negative is a negative. 15 goes into 45 3 times. And then the D cubes just cancel. Okay, so this is your final answer on that one. All right, question number 5. There's no numbers on this one, super easy. So we're just gonna say, what do they have in common? 1, 2, 3 C's, 2 C's, and 1 C. What's the most that they have in common? Well, the most I can circle that's the same in all of them would be 1 C. So I'm gonna pull that out. So I'm gonna put a C on the outside. I'd say, well, I've got 2 C's left here. I've got 1 C left here. Don't forget this one has a negative stuck to it. So we would write minus, and if I'm taking out the C, this is where you have to be really careful, because it's not that there's nothing left. Remember, we were saying like if you're taking it out, you divide by it. So C divided by C would be 1. So we leave the 1 there to kind of save the place so that when we multiply it back in, it can end up there, because C divided by itself, anything divided by itself equals 1. And when I multiply by 1, it's just whatever that value was. Okay, so that one was a little bit tricky because of that. Moving right along to question number 7. Man, time flies when you're having fun, huh? Okay, just kidding. All right, so this one we're going to try subtracting. 7 minus 10 is 3. Or sorry, 10 minus 7 is 3. Can 3 go into either one of those? No. Can 7 go into 10? No. Is there anything besides 1 that can go into 7 and 10? No. But what they both have in common is they both have an M. So we're going to pull that out. So if I have 7 and 2 M's and I take one of the M's out, I just have 7 with 1 M left. And then if I had 10 and an M being multiplied and I divided out the M, all I would have left is the 10. So that's it. We're just pulling the M out. All right, question, oops, sorry. I was gonna say, you should have said something, but you guys can't talk to me. All right, hopefully you guys can see that now. Sorry about that. And then question number 9, you're gonna say, what do they have in common? They both have a 5 and they both have an X. So if we divide by 5X on both of those, all that's left from this first one, the 5's cancel. I have 1X left over. 5X and 5X are exactly the same. 5X goes into 5X 1 time. Okay, so anytime it's exactly the same, we're going to put a 1 there to save the place. So that when we multiply it back, it ends up where it's supposed to go. Because we're just dividing, we're not subtracting. So I'm never going to get 0. But if I'm dividing by exactly everything that's there, we're going to put a 1 there. Okay, question number 11. Look at the littlest number, 4. Can 4 go into all 3 of those numbers? Yes. And whenever we're leading with a negative, we tend to take out that negative at the beginning. And then I say, do they all have R's? Nope, that last one doesn't have it. So all I'm doing is dividing by -4 on each of these. Okay, so I'm going to put what's left. -4 divided by -4. Well, all I just have is the R squared. A positive divided by a negative is a minus. 4 goes into 4 one time. If it's just one R, I don't write the 1 with the R. You could, technically, not wrong, but it's not in the most simplified form. 8 divided by -4 would be -2. That's your answer for that one. We're almost done. It's taking forever, huh? All right, good job persevering, you guys. Number 13. Look at the littlest number. Does the littlest number go into all 3 of those? Yes, it does. And whenever we lead with a negative, we typically like to pull that out. So I'm going to pull out a -2. I've got 5 D's, I've got 2 D's, and I've got 0 D's. So they don't have any D's in common, right? Because this third little guy doesn't have any. So I cannot pull it out if they don't all have at least that many. So all I'm doing on each of these is dividing by -2. So I have positive 10 d to the 5th. I've got -5 d squared. And remember, anytime I have the same thing divided by the same thing, we put a 1. And because it's a negative divided by a negative, I need to put a plus there. And then you could always check your answer, multiply it back out and see if we get what we started with. All right, you guys, one more. We are almost there. Thank you for paying attention. Hopefully I wasn't going too fast or too slow. All right, question number 15. We're going to look at these. I look at the smallest number, and can 5 go into all of those? Yes, sirree, it can. I sound like I'm like 80. Yes, sirree. I'm just kidding. Okay, so I'm going to put the -5 down there, and then we're going to check the A's. So there's 8 of them, there's 7 of them, and there's 3 of them. So the most that I can take away or divide out from all 3 of them would be the 3 A's. So it's always going to be the lowest one because that's the most that you can take away the same from all of them, right? I can't take away 8 from here or here. I can't take away 7 from this one. The most I can divide out from all 3 of those would be a to the 3rd. So I'm going to put that out in front. So I'm dividing by -5 a to the 3rd, -5 a to the 3rd, and -5 a to the 3rd. And so we're going to see what is left. So a negative divided by a negative is a positive. 50 divided by 5 is 10. And if I had 8 A's all being multiplied, and I've got 3 A's being multiplied, and I cancel out 3 of them, I've got 5 left. So I'm going to write a to the 5th. Then I have a negative divided by a negative, which is a positive. The 5's cancel to make a 1. We don't have to write the 1 when there's still some letters left. If I had 7 A's and I'm dividing out 3 of them, I would have 4 of them left. And then I have a positive 25 divided by a -5, which is a -5. I had 3 A's and I am dividing out all 3 of them. So there are no A's left on that part. All right, you guys, and you did it. We just factored out greatest common factors for a whole bunch of problems. Hopefully this makes sense, and have a great day.